Another method of breaking parent-child relationship is based on task scheduler. Task scheduler is a well-known method for persistence or lateral movement, right? But it can also be used for spoofing parent ID of a new process. And usually what we use is get tasks, right? Command, which allows you to create tasks even on a remote machine. And yeah, that's one of the ways you can interface into task scheduler. And once the task is created and run, it will be spawned by a process by the service which is running a scheduler, task scheduler, and this is called it is called surprise scheduler. And where is it? Schedule, right? And it lives in this process. So yep, task scheduler. So anytime you run a task, the process will be created as a child for SVC host hosting the schedule service. Now we don't want to use command line because it's detectable and it's well monitored and understood by blue teams. For this, we will be using the WinAPI interface. Okay. So let's go to our implant and let's go through the code. So to get to the task scheduler, we will be utilizing a COM interface. And COM is an ABI or application binary interface. In other words, it's a way to load a dedicated library and use it via a standardized interface. Okay, and calls are made by invoking object methods. All right. It seems complicated or sounds like complicated, but at the end of this module, I believe you will clearly understand what is going on here. So if we want to use, if we want to get to any service which is available via COM, we first need to initialize a COM library in our process. And after that, we call a standard co create interface call, pointing what kind of so to speak service we want to use. Okay, and in our case it's task scheduler, and that call returns a pointer to an object, and this object will allow us to interact with task scheduler. Okay, so this object is a sort of interface to the task scheduler. So once we have this interface, we then create a new task, and this task is also an object. Okay, some kind of object which has some methods and some fields. All right, to set the fields, and this object actually represents a task we are creating for our purposes. So to set the fields in this object, we need to call several methods exported by this object, or available by being available from this object. So to set a comment, we call setComment method. If we want to define the parameters for our command, then we use set parameters method as well, and so on. Okay. After setting all the needed information for our task, we also can set specific flags on it. I will, and yeah, we are just setting run only if logged on flag, but there is also another one which is called task flag hidden, and I will cover that a little bit later. Okay. After that, we need to save this configuration into the disk. Okay, and to do that, we need to call for another object, which is called persist file, and that object will allow us to save our configuration to the disk and be available to be, to the task scheduler. After that, we just call run on our task, and if all goes well, then our our process we defined, our binary we defined here, will get executed as a child of the SVC host process. All right. All the tasks are saved in this folder. Okay. And once it's done, we can release all the objects, so clean up and yeah, go home basically. So let's compile that and let's run it. So let's go to here, compile it, and let's run the guy. Okay, so let me show it. Show what's so this is our implant. Let's go to modules and see what happens step by step. Okay, so we are actually right now we are at the beginning of our code. Okay, so first thing, we initialize a COM library. Okay, so let's hit enter, and you see that two libraries has been loaded. Okay, like 2 additional libraries. Now the next step was to get an object for task scheduler. All right, so let's do that. Hit enter, and this loads two DLLs. Okay, and as I told you at the beginning, COM is basically COM model is basically a bunch of DLLs which implement specific functionality. So in our case, task scheduled COM objects are implemented in mstask.dll. Okay, and that is why this object has been this DLL has been loaded into our process. Next step was it's up, so then we should our task run. So let's get back to our source code. So we have said that we want to run an application notepad with parameter to this file. So in other words, notepad should open up this file for us, which is the case, right? boom.txt. And let's take a look at where it lives. So we don't have notepad as a child of implant, but instead it is a child to our task scheduler, right? Here. And let's get back to implant modules, right? So the next step, we are here right now. Okay, so let's take a look at this folder as well. So let's go to C, Windows, tasks, and here is our execme.job file, which contains the definition of our task, and this name was set here. Okay, so it can be configured. And what happens if we hit enter? So task removed, Now as you can see that the task scheduler interface has been unloaded from our process because we have released the object and uninitialized the COM. So yep, that's how this code works. Okay, let's let us see what happens if we change these flags and add a task flag hidden. Okay, so let's recompile it. Okay, close that as well. Compile and run it again. Schedule is up. Okay, so this is, and let's take a look in the tasks folder. Refresh. We don't see anything. Okay, so no job file has been created. Is it true? If we open up another window, CMD window, and see, so this is actually what we see in the Explorer window, but if we list hidden files, we see that our file actually was created and is present on the disk, but it has a hidden flag set. Okay, so this is what this setting changes. And if we hit enter, we shouldn't see this file anymore. Yep, it's gone. All right, so yep, that was our method for utilizing task scheduler for breaking the parent-child relationship. Of course, this technique requires if you want to run your implant as a separate process using task scheduler, you will have to drop a file to disk, right? So the next step, let's actually see how this COM interface works under debugger. All right, so before we start our debugging session, we need to add one thing, which is debug break. So we are adding breakpoint, and let's recompile. And let's run it. Attach debugger, implant, cool, run it, hit enter. So we are, and let's get rid of this breakpoint. So space, nup, enter. All right. Okay, so we are here. So let's F8. F8. Now we are calling call initialize function. So we are initializing our COM interface. That's fine. We have our message. So hit enter, and now we are going to initialize our create instance, right? So now we are here. Okay, now we are here. We are going to call co-create instance and to get an interface to an object. Okay, so let's do that. And so let's F8. So EDX is 0 now, right? So RAX holds some information, some address on stack. Okay. So let's follow this in dump. Then, and this actually is what? CF8. So this is this position. Okay. R9 is taking some value, and R9 is, so RCX, RDX, R8, R9. So this value is an identifier of for task scheduler. Okay, it's fine. We are storing what? Something on stack is again. Oh, so that's the pointer to the address. So okay, so it means that this address, so this is the address of some position on the stack, and since we are passing 5 parameters, so with x64 calling convention, that would mean, so first parameter is RCX, second RDX, third R8, R9, fourth, and the fifth parameter, and all others would be passed through the stack. So this would mean that this address should be, after we return from co-create instance call, it should hold the address of our object to schedule task scheduler. Okay. RCX. So let's go further. RCX is the first parameter, which RCX, right? So this value, what is this? Is okay, so that's the identifier class ID for task scheduler, and R8 is set to 1. That's cool. So we are not going to go step into, we step over, and now we have something here. Let's see what is this. So let's follow this in dump. Okay, so this looks like some pointer, right? 7F. Yeah, it looks like a good candidate for a pointer to an object. Let's see what is there. Let's follow this in dump 3. Yeah, it looks like a table of pointers to specific functions, and let's see what where this leads us. And we landed at mstask.dll. Okay, so again, we have we came back from this call, and this variable holds an address to an object, and actually this is the pointer to the table of functions which are available in that object. Okay, this is the vtable. So let's get back here, minus. Okay, and let's go further. So now we're good. We're checking the return value. That's cool. Yeah, it was successful. So we are going to do what next? Okay, we're going to print something. Okay, F8, F8, F8. It's running. So yeah, task scheduler object is up. Hit enter. Now we'll get back here. And what's the next step? Now we are going to create a new task. So we are going to call a new work item method from this object. All right. So yeah, you can even see here that we are calling through referencing a registry, and RAX is set by RCX, and RCX would be set here. So let's see what RCX is. Let's get back previous. Oh, okay. This one, let's see again what this address is. It's number 2. Okay, this is our address object returned by this call. Okay, so this is address of PITS. Okay, makes sense. So in other words, we are going to call this this method using a reference to the object we get from here. All right, and to get that, it is actually RAX plus 40. So let's set a breakpoint here and hit run. So RAX is, so let's put it down 3. Okay, plus 40, which means 1, 2, 3, 4. So we are referencing 78. So this address. So in other words, calling this will call this pointer, which leads to some function which is in mstask.dll, and probably it is new work item. Okay, that's how this object-oriented programming magic looks like. Okay, so let's hit F8. We're cool, and we should be getting some data, some return value as well. Let's try to find that. What is next? Coinitialize. What is this? RSP plus 60. Okay, let's move there. Let's remove that. We're jumping, we're not, this is all successful. So the next step is we are going to utilize these methods of PITask, right? But we need to find the address. So let's see what is in RSP plus 60 is this address. What is this? FFCF0. FFCF0. So this is this address. And okay. So F8, RCX now holds. So let's see what this. So this looks like another pointer. Let's follow this. Okay, so it looks like another pointer to another vtable. All right. Cool. So we have 1, 2, 3, 4, 5 calls using this pointer. And we have 1, 2, 3, 4, 5, 4, and the sixth is this one. Okay. So, yep. I hope you understand that right now. We are going to call these 5 methods one by one, giving them specific parameters. Okay, so the first call is to RAX plus 90. So if we add 90 here, it should give us some pointer down there. If we call another one is plus 100, it should be 80, this one, okay, and so on and so forth. So let's go through it. RDX is pointing to somewhere. Let's see what this it holds. Come on, Notepad is legit, which is our first parameter for this setComment method. So it means that this call will actually reference this method in a PITask object. Okay. Next one, what is this? Let's see this. Into it is Windows System32 Notepad. So it's a path to our application, right? Yep. So this call RAX plus 100 is this method, and so on. So the next one is Windows. Okay, so this is our working directory. Okay, so plus 120 is this method, and so on and so forth. So I'm not going to cover the whole code, but now you can see how it's how it works like on a low level, all these calls and methods and the whole magical COM object and COM interface. All right.